All right, so let's go over our homework here. We did what, 110 to 112? Was it 102 to 112? That would only be 2 questions if we did that much. All right, 102. You should have -2 and 8. And number 104, you should have -1 and 1. So any questions on those two? No? 106 should be 3,125. And 108 should be e to the second and 1 over e to the second as your exact answers. Yep, I'm going to tell you what e to the second is real quick though. If you did the decimal for e to the second, you got 7.3891. And then if you did 1 divided by e to the second, you got 0.1353. 82902. Oh, yep, that would be the same thing. Because remember what negative exponent does? It pushes it down to the bottom. Which one did you want to see?
6.
Okay, give me the original.
Log 5.
Log base 5?
Yeah, log base 5. Parentheses log base 5.
Okay, so I have to get at this x right here. And I can't do that until I get rid of this log and I get rid of this log. So my only option is to rewrite it. So this would be 5 to the first equals log of base 5 of x. Well, 5 to the first is just 5. And now again, the only way I can get at that x is to get rid of the log. And the only way that I have to do that is to rewrite it. This would be 5 to the fifth equals x. And I hope that 5 to the fifth, that fifth is 3,125. All right, so now I'm at 110. 110 should be no solution. You just get -2 and that does not work. And then 112 was a long one. You should have the ln of 1/3 and the ln of 7 as your exact answers. ln of 1/3 is -1.0986 and ln of 7 is 1.9459. How's that feel, baby? What's that? That's just the exact answer. Either of those answers would be acceptable. It just is dependent on what the question asks you for, exact or approximate. Did you get the right ln though?
No, I just have 1/3 and 7.
Oh, well, tell me what your last line is. Like before that.
I just have the back there of it.
So you have that u is 1/3. Oh, you didn't do substitution? Okay, so give me the start. Start from the top. What you got?
3 e to x parentheses e to x minus 6 equals 4e.
Like that. Okay, so did you distribute first? Okay, so this will be e to the 2x minus 18e to the x minus 4e to the x plus 7 equals 0. Is that okay? I moved them all over? You're right, should be 3. Is that okay then? I'll put these together to get -22. And then what did you do? You factor it?
Yeah.
So did you say 3e to the x and e to the x? And then you should have a 7 over here and a 1 right here, and then minus minus. So then did you set these equal to 0? Yeah? And then you said this one equal to 0? Okay, so how am I going to solve this? I got to get rid of the 1, I got to get rid of the 3, right? So e to the x equals 1/3, and e to the x equals 7. Now if I want to solve for x, I got to get rid of the e. The only way to do that is to rewrite it. And so it'll be the ln of 1/3 equals x, and the ln of 7 equals x. Okay? And then that was it, right? Okay. So you can go ahead and put that homework away. Today will be your last assignment that you have to do. Obviously, I always give you your review assignment, and I always give you the assignment that goes with the day before. So you'll have that. Okay, so today we're going to talk about using this stuff with word problems. And honestly, they have to give you the equations. This is not something that you're going to be asked to write your own equation. Thank goodness, right? Okay, so there'll be a lot of, here's the equation, now can you solve it? Basically is what this is going to boil down to. So today, we are going to work on solving for certain variables. Because then tomorrow when we plug the numbers in, you'll obviously still have to solve for a variable. So when do we use this stuff? Basically 2 places. Growth of population and investment. So, is our population increasing or decreasing? A lot of times the equation you use to find this has a log in it. Or it has a exponential function within it. And then decay. I don't know how much they talk about decay in science class. You guys have ever heard of like carbon half-lives and things like that? Well, that uses logs and exponents. Okay, so there is real-world application. It's obviously very complicated, and a lot of times they have computers that do them for them. But of course, you don't have the luxury right now. But it's not too bad. So let's go ahead. I've got 5 examples for you today. You are just going to be solving for whatever variable they tell you to solve for. So if I'm looking at number 1, this thing has 3 variables in it. It has an uppercase T, it has a lowercase k, and a lowercase t. Remember, the e is not a variable. That's a constant number. It's like pi. So I need to solve for k. The k is right here. So what do you think I need to get rid of first? Perfect. Subtract it. Okay. What do you think I need to get rid of next? 272, we're going to divide it because it's being multiplied. And now is where we have to use what we've learned. Because I can't get at that k until I get rid of the base of e. So I need to rewrite it. If I'm using a base of e, what are you going to use? ln. And remember how we rewrite this. The ln of what's on the other side of the equal sign is equal to the exponent. And now it becomes very easy to isolate the k. What do you have to do finally? Divide by negative t on both sides. So I think what I'm going to do is I'm going to put the negative symbol out front. And then the t will be down there by itself. And that is what k equals. We're just isolating the variable they tell us to. I don't know if you guys remember when you first did this in Algebra 1, when you would be given equations with literally no numbers in it, and you would have to isolate what they tell you to. Okay? Same idea, just kind of amped up a little bit. All right, so let's look at this one. Now I'm solving for t, which is right there. So what do you think I need to get rid of first? The 90, and we're going to subtract it. And then we're going to get rid of the 20. And again, what's that? Yep, divide by negative 20. I'm going to put the negative out front. And it now looks like that. Well, if I want to isolate for t, I got to get rid of the ln. And the only way to do that is to rewrite it. What's the base on the ln? E. So this is going to look a little strange, but it's e to the negative s minus 90 over 20 equals t plus 1. And last but not least, we just need to subtract that 1 over. One thing you could do here, guys, is you could distribute the negative symbol up in the numerator. If you didn't like it hanging out up here, that would make it a positive 90, then minus s. So the top could be 90 minus s instead of s minus 90. Or really, you could put the negative down with the 20. It's no problem there either. Questions? Okay? All right. So now I want to solve for this H plus. And I would assume this would be like a chemistry example. Okay, talking about electrons. Honestly, that's about all I can give you because I don't really remember much from my chemistry. So if I want to solve for the H plus, what's the first thing I got to get rid of? The negative symbol first. So this now dividing by a negative 1 becomes negative pH. And now we'll get rid of the log. The only way for me to get rid of this log is to rewrite it. What's the base on this? 10. So this will be 10 to the negative pH equals H plus. And the H plus is isolated. Because this isn't multiplication. Remember, we're taking the log of that number. All right, this one deals with money. Anybody in financial management might have seen this before. P stands for principal, T stands for time, R stands for rate, and then the A stands for the amount of money that you would have. So I want to solve for T. What do I need to get rid of first? What's that? The P, how are you going to get rid of it? Divide by it. Now if I want to get rid of the T, I have to get the 1 plus R off of there. You all see that? Well, normally when we get to this point, you rewrite it. But I don't have a whole lot of anything to use to rewrite it. When we rewrite it, this is your base, isn't it? You want to use log as your base, or do you want to use ln? Does it matter to you? Okay, well, let's use log then. Log base 1 plus r of a over p equals t. I think this is the first time we've seen a variable in our base, right? Like that. Is the t isolated? It is. Now, it's not really proper to leave it like this because this looks a little bit silly, doesn't it? Well, if you were going to put it in your calculator, you'd have to use your change of base formula. Remember that? Not really. Okay, so how do we do the change of base? You take the log of what you're taking the log of divided by the log of your base. So this would be log of a over p divided by the log of 1 plus r, and it's still equal to t. We're just using that change of base formula that we talked about. Gosh, I think it's been a week now. It's been a while. Actually, I think you guys had that on your last test, didn't you? Because there was one that, remember, you had a silly mistake on it. The change of base formula. All right, this is my last one. Okay, I want to solve for k. And the k is right there. So what do I need to get rid of? The ln. And the only way I know how to do that is rewrite it. What's the base on ln? So this will be e to the negative e over rt equals k over a. And again, this is just rewriting this like we learned at the very beginning, changing it from logarithmic form to exponential form. And what's the last step to solve for k? Multiply by a. If you want to put parentheses around the exponent, you're more than welcome to. You don't have to. But that would be your answer. Okay. Those are your notes for today. Your homework is all about solving for variables, and it is those problems. Let me know if you need help. You will have a couple of these on your test on Wednesday, and then we'll have one more day of notes tomorrow. Your review has been posted. It's up there for you to look at. And you can always, of course, let me know if you have questions on that review.